Okay, this concept is dealing with equations in one variable. And it uses this diagram, and it shows you, okay, you've got two segments. Here's a segment, there's a segment. They're the same length, and it wants you to use the fact that this and this segment are the same length to find what x ought to be. Now, for Ask Dr. Callahan students, this corresponds to Algebra 1, page 217, number 9D. For everybody else, you can just follow along. What you do is that since this length up here is the same length as this down here, we can set these two equations equal to this equation, right? It's like if there are two pieces of rope and it's one side, one piece of rope is this long, and the other piece of rope is two pieces tied together, then you have x plus, this. So whatever this equation equals, that equation has to equal the same thing because they represent distance, and in this case, the distance is the same. So now we have what's called a single equation in one variable. That means I have, an equation, which is anything with an equal sign, and I have one variable, x. So I start by solving the problem. 2 times x is x, and again, this is the distributive property here. 2 times 10 is plus 20. And then on this side, I just leave the x alone for now, and I do the distributive property over here. 6 times x would be 6x, and then 6 times 2 would be 12. Now I can go back and add like terms. I'm going to leave this side of the equation alone for now and come over to the right side and say, well, 6x plus x would be 7x. So now I have this equation. What I want to do is get all of my x terms on one side and all of my y terms, all of my numbers on the other. So I'm going to actually, and that's not what I'm going to do, I'm going to actually, assuming I can make this work, I'm going to select this here and take it over to a new page so I can work a little better and you can see sort of what I'm doing. Again, this is 12. I'll try and make that a little prettier. It didn't really work, but you can tell what it is. Okay. It doesn't matter if you, subtract 2x from this, from both sides to get, your x's over here. Or if you were to, do it the other way. Just pick a side and say, okay, I want this to be my numbers side, and I want this to be my variable side, and just be sure to stick with whatever you choose, okay? So now I just, again, combine like terms, leave this alone for now, and 7 minus 2 is 7, 6, 5x plus 12. Now I subtract 12 from both sides, and 5x, excuse me, 5x equals, let's see, 10, 9, 8 equals 5x. So then x has to equal 8 divided by 5. And you can leave that as a fraction or you can convert it to a decimal, and it just completely depends on your preference and your